All right, example number 8. We've skipped a couple here. We're going to jump ahead to example number 8. And again, we're estimating an average, estimating a mean. I guess the title slide again, when you're estimating a mean, every question on this double assignment 21-22, you're going to be estimating a mean. And you'll use this as your guide. But I want to remind you there's two types of questions, confidence intervals as well as possibly a sample size. And if you've had a chance to read the question, I suggest you read them before you watch the video. But I hope you're noticing right here it says, how large of a sample must be selected? How large of a sample? It does not ask us for a confidence interval. It asks us for a sample size. How large of a sample? All right. So sample size, and we're estimating a mean. As we mentioned, as Mr. Sonogram told you earlier on this assignment, if you're doing sample sizes for a mean, it'll be this. I put the sample size formulas for proportion on the same slide. And this half of that flow chart was basically assignment 20, proportion. Okay, but we're on 21-22, mean. There it is. So there you go, you pop it in there. I forgot to put the squared on that. Put the formula in. Okay, get that established first. That is imperative. We don't get the right formula, we're not going to get it right. We're just not. Okay, unless something really magical happens, which I don't see. All right. So n equals. All right. I typically, as you know, whatever the table is that we're going to use, z or t, I usually save that for later. So let's skip that. Sigma would be our symbol for standard deviation. And it says the standard deviation is 6.5. Error, it says right there, error 1.25. These are not percentages. We're not moving the decimal. These variables are not percentages. And then z, which again, that goes back to our logic we've seen before, 95% confidence. So here we go. Hey Z, how you been? Good old bell curve, 0 in the middle. 95% confidence, otherwise known as 0.95. We want the middle 95% of the bell curve. So we put half of that 95% on the lower side, and we put half of it on the upper side. You guys remember when we were doing this is go back to assignment 16. Find the two z-scores that surround the middle 95% of the bell curve. So 4750 is half of 0.95, 0.475. You will note that both of those are middle slivers, aren't they? And doesn't that make this particular table really happy? Do you guys understand now why I love the middle sliver table so much? It's perfect for these kinds of questions. So you go, hey table, I got a bell curve picture here with a couple of middle slivers of 0.4750. Table time. So middle sliver 4750, perfect, it's right in there, 1.96. After a while you get to know where these things are. But anyway, 1.96 would be that number in there. And it isn't going to matter whether we do the plus or the minus because it's going to get squared eventually. So there you go. And so 1.96 times 6.5 divided by 1.25 and then squared, order of operations. This comes out to be 103.87 blah blah blah. And let's always remember that sample sizes, right? You're reading the paper, a survey of so many such and suches. Well, that's got to be a whole number, isn't it? So again, I would simply remind you that we're going to round them up, right? So 104, round it up, 104. Okay, now look, I've seen this question a lot, and questions like it. people frequently put the wrong label on this. And that's a dilemma for me as to whether you put the right label. See, a lot of people look at this and they'll say, oh, I'm going to survey 104 sick days. Sick days is what we're measuring. Sample sizes would be, who are you surveying? All right? And you're not going to call up a sick day and ask them a question. Who are you surveying here? You are surveying, it says so in the narrative, full-time food service workers. They want to estimate how many sick days are used by full-time food service workers. You're going to survey 104 full-time food service workers, and then you're going to ask them how many sick days, right? So let's not confuse the variable we're measuring with the population that we're going to survey, all right? So anyway, that should be the proper label for that number. I hope that made sense.